Morning students, welcome to the Science 1 class. Today we are going to learn in detail about the fourth application of Avogadro's law, that is relationship between vapor density and relative molecular mass. We have already learnt about relative molecular mass. Now, let's learn a definition for the relative molecular mass of a gas or wafer. Mass of one molecule of the gas or wafer when divided by the mass of one atom of hydrogen, we'll be getting a value, and that value is called as the relative molecular mass. Let me repeat. Mass of one molecule of the gas or wafer divided by the mass of one atom of hydrogen is called as the relative molecular mass. Now, let's move on to the next term, wafer density. You know what is density? It is mass by volume. Now, we are going to take a gaseous molecule and hydrogen molecule in two separate containers. But the volume, temperature and pressure of both the containers are the same. We have to find the mass of both the containers and the value which you get by dividing the mass of gas by the mass of hydrogen is called as the wafer density. So, wafer density Vd is equal to mass of a given volume of gas or wafer at STP. STP denotes standard temperature and pressure by mass of the same volume of hydrogen. And the formula for the relative molecular mass is mass of one molecule of a gas or wafer at STP divided by mass of one atom of hydrogen. Students, you should learn both the formulas thoroughly. That is relative molecular mass and wafer density. You know that wafer density is equal to mass of a given volume of gas or wafer at STP divided by mass of the same volume of hydrogen. What is said in the Avogadro's law? Equal volumes of all gases contain equal number of molecules. Suppose if we take number of molecules as n, then the vapor density formula can be written as vapor density is equal to mass of n molecules of gas or wafer at STP divided by mass of n molecules of hydrogen. So, instead of given volume and same volume, we are writing as n molecules. When we cancel n above and below, then we'll be getting as wafer density is equal to mass of one molecule of gas or wafer at STP divided by mass of one molecule of hydrogen. In the wafer density formula, we have written as hydrogen molecule. What is the molecular formula of hydrogen? Yes, it's H2. What is the atomicity of hydrogen molecule? It's 2. Since hydrogen is diatomic, vapor density formula can be written as vapor density is equal to mass of one molecule of gas or vapor at STP divided by mass of two atoms of hydrogen. So, we have changed one molecule of hydrogen as two atoms of hydrogen. Now, we are going to compare the vapor density with relative molecular mass. Again, we are going to write both the formulas. Vapor density is equal to mass of one molecule of a gas or vapor at STP divided by, here instead of writing mass of two atoms of hydrogen, we are going to write as 2 into mass of one atom of hydrogen. And the same relative molecular mass formula. Relative molecular mass is equal to mass of one molecule of a gas or vapor at STP divided by mass of one atom of hydrogen. In the vapor density equation, when you remove the 2, what will be the remaining term? Yes, vapor density is equal to mass of one molecule of a gas or vapor at STP divided by mass of one atom of hydrogen. And that is equal to the relative molecular mass. So, we are going to substitute the relative molecular mass equation to vapor density equation. And we will be getting vapor density is equal to relative molecular mass by 2. It can be written as 2 into vapor density, that is equal to relative molecular mass, or relative molecular mass is equal to 2 into vapor density. Students, that's all for today's class. In this video, we have learnt only one concept, that is relationship between vapor density and relative molecular mass. Thank you, students. Have a good day.